Got here a 1964 Fender Deluxe non-reverb that I did a lot of work on in 2018. All 64 iron, that's nice. The owner said that they're using on sessions one of the main go-to amps for tracking in their studio, and it started blowing fuses. And it came in, and it indeed had a blown mains fuse, the correct 1 amp. So I'm just going to go in and see if I can find the culprit. And I've got a couple of things in mind. But the first thing I wanted to check are the filter caps that I installed in 4 of 18. They certainly look okay. I'm going to keep this open for now, just making sure the transformer hardware is tight. It could just be something simple, like a bad rectifier tube. It's got a ruby, which is, I believe, Chinese. And it's got a pair of Electro-Harmonix 6v6s. Either one of those could go bad. So I'm going to pull each tube and give them a shake and listen. There's a tiny little bit of a rattly sound on this Ruby GZ34. I don't see material in there. It may be okay. I'm putting it to the side. I'm going to do the same, kind of shake and listen to the 6v6s and look for discolorations. Makes no sound. Doesn't seem to be discolored. That's that first one. Put it to the side. No sound. No discoloration. None of them have lost vacuum. That does not mean that everything's fine, but weeds out some common causes. Don't have a fuse in it yet. I'll put one in and then power this up on a current limiter, which will let me see if we have any woes. It's got the original bias circuit resistor and diode. Changed out the cap back in 2018. It still has the original screen grid resistors, either one of which could be at fault. It has original grid stoppers, either one of which could be at fault. I'm going to measure these. I often replace these on site, but this was such a clean example of a 64, other than previous tech had there might be a replacement choke, given that wire there that's got heat shrink on those leads. Let's see, this amp was last here in 2018, so I don't recall. Yeah, that's a replacement choke. Okay, so replacement choke, original output and power transformers. Aside from electrolytic caps, I believe pretty much original everything. Let me check my notes real quick to see what all I did. Previous tech to me had put these 1 ohm cathode resistors in, which I'm not a fan of, but if they're working, I don't automatically feel the need to remove them. Let's see, in 2018, problem found. Amp had been serviced by multiple techs over the years, different electrolytic caps installed at different times. 4 electrolytics, 2 filter caps, 2 cathode bypass caps, leaking badly, all old and needed replacement. All those replaced, F&Ts and Vichets. The interstage dropping resistors replaced with 3-watt metal oxides. Blah, blah, blah. Some resistors were replacements of wrong type. Some original resistors had drifted badly in value. The following resistors were replaced with half-watt carbon comps. 100K cathode for V3B, 220K plate for V3A, 820R cathode for V1B, V2B shared. So, all right, I changed out this resistor, and I changed out this resistor, and I changed out this resistor. All the others are original there. Let's see, several bad solder joints throughout amp. Old solder dirt and flex removed, components resoldered properly. Amp had all original blue Ajax film coupling caps except for the 200 volt 0.1 in the phase inverter, which was an orange drop. I had an an original Ajax in my stash. I didn't put that in there. Many jacks and pot nuts were loose. Pots were dirty and scratchy. Hardware tightened. Pots cleaned and lubed. Normal channel excessively noisy. Bad 12x7. Moved existing 12x7 from V3 to V1. See next section. Tremolo weak, too fast. These caps had drifted. Spoke to the owner. Owner said just disconnect the tremolo. He doesn't like it. He doesn't use it. And the amp sounds better without it. So I did. Then owner had purchased new old stock tube set for amp, but tubes and amps are Ruby labeled Chinese and Russian tubes. Existing tubes are working well. Let's see what I'm saying. I'm not quite sure what this means. It meant something at the time. I think he thought it had new old stock tubes in it, but I was just confirming that the tubes in it were all Electro-Harmonics and Ruby. And I have a note of where I biased it. It was biased as 51% idle when it left, with a B plus of 400. Amp had a 2-conductor power cable, noisy and unsafe, replaced with the proper grounded power cable wired to modern safety code. And when it came in, originally it had a 3-amp fuse instead of the 1-amp. I installed the 1-amp and put a note in there that you must use a 1-amp. The one that was in here that was blown was indeed the correct 1-amp. So I'm glad that the owner did that, because if he'd used a 3-amp fuse in here, whatever was blowing this 1-amp fuse might have burned something in this very clean example of a 64 Deluxe. So let me do a visual inspection. See if anything has come loose. Everything looks pretty good. I don't necessarily see any places where this component's pulling out of the old solder. So let me measure the resistors on the output tubes, and then we'll see if it's just a faulty rectifier or 6v6. So let's measure the screen grids first. Should be 470 Rs. And 505. 515. Little high, but not out of the ordinary. They don't have any discoloration. They may be fine. The grid stoppers supposed to be 1.5 Ks. These often drift a little bit high because of the heat over the years. 1.6. 1.64. That should be okay. So with output tubes and rectifier tube out of the amp, I'm going to power this up through my current limiter and see if there's any problem with the output tube and rectifier out. If there is a problem, it's going to be in the heater supply, and that can tell us a lot. I just like to do this one thing at a time, wherever possible. So test that the heaters are good, then I'll put in the rectifier tube, make sure the rectifier tube is good, and that the 5-volt tap and the HT is good. If all that passes muster, then we'll put in some 6v6s and see where we're at step by step. All right, I got a 1-amp fuse in there. I got on the current limiter. We're going to power it on. No excessive current draw. That's good. And I believe I should still have bias here even without the. Yeah, I should. So let me see what the bias is at each pin 5 on the output tubes. -40. -40. So far, so good. Power it off. put in this rectifier tube, we may get a light show just from a rectifier tube being in place. All right, so power it on. So far, no crazy current draw. Let's see what our voltages are. So with no power tubes in the amp, and the amp in standby, the HT out is 479 unloaded, and AC at both points. Let's see, on the HT 684, and it should have about 5 on the 5.3. That's all good. All right, so far so good. Let's tap on this tube, make sure we don't get any sparks. I repeat, don't do this kind of thing if you don't know what you're doing. I've got a current limiter that'll keep anything in the amp from burning when this happens. All right, so far so very good. Now we have the fun of 6v6s. And will these want to release magic smoke or not? These are the biggest current draw in the entire amp. And so I'm going to start it. While this amp technically does not need standby because of the tube rectifier, I'm going to use the standby because that will let me isolate whether there's a problem with the current draw through the heater supply with 6v6s versus a problem in the B+, the DC draw on these 6v6s. And again, right now, staying in standby, I have no speaker cable attached. So let's let these all warm up. And set the channel volumes at 0. And I almost said set the reverb at 0 because I'm so used to Deluxe reverbs. And while those warm up, and I'm watching the light bulb, now I will install a speaker jack. And before I take it out of standby, I'm going to rearrange where it's at physically and see what the heater voltages are at. .46. All right, let's take it out of standby. And I'm going to watch the output tubes, and I'm going to watch my current limiter. I'll set it so you can see the output tubes. It's a little microphonic, but nothing else. All right, let's check those voltages on those tubes. And I'm going to keep an ear out. There's a slight hum in the background. I'm going to see if it increases as I do any of this. It's telling me that one of the tubes beginning to red plate because I can't see them while I'm up top measuring things. Let's see here. Untangle my meter cables because I love to tangle. And just rest that against the chassis for a constant ground reference. All right, so pin 3 on each. 377. 373. All right, it's fluctuating. The wall voltage is 119. It's got 373. 368 now. Bias, negative 36.4, negative 36.4. Screen, 373. $372. I think that's just fluctuation. Now, what's interesting to me is that when I last had this amp, I had a B plus of 400 volts with the tubes idling at 51%. And now that 400 volts has gone down to 373. I think someone has biased this amp too hot. Let me power it off, let things cool off, and I'm going to measure where the bias is at now. And let's see if someone tweaked this and set the bias too hot, because as the bias current draw increases, the plate voltage decreases. And so to go from an amp with 120 volts mains that had a 400 volt B plus to the same amp at the same mains having 473, either those tubes have drifted really crazy or someone was messing with the bias. So let me call up my calculator and see where we're at. Okay, well, I just learned a very interesting thing. While the voltages at plate and grid and screen were consistent between the output tubes, this output tube is idling at 18.8% dissipation. This output tube is idling at 81.1% dissipation. Now, that tells me a couple things. It tells me that one of these tubes is probably bad, or there's a big problem with the socket. Given that the voltages and resistances measure the same, I think it's probably the tube. That hum that I'm hearing is going to be because the tubes are drawing very different amounts of current, so there's not going to be the common mode cancellation there should be. If one of those tubes is idling at 81%, it's likely to arc in use, which will then cause the blowing fuses that the owner's complaining about. And that's also why we're going to have the artificially low B+. Now, next thing is to find out whether it's the tube or the socket. So this tube was at 81%, this tube was at 18%. There's a nice symmetry to that. I'm going to swap the tubes around and see if the 81% stays with this tube or stays at this socket. If it's the socket, then I've got some other things to do and check, including the possibility of leaking DC from the original 1964 coupling cap, but that's unlikely given that the voltages measured at pins 5 were consistent from tube to tube. Usually if there's leaking DC, one of those would be a lot more negative than the other. And the one that was getting 81% should have been the one that was a lot more negative than this one. But those tubes have been swapped, and I'm going to remeasure and rebias now and report back. Well, I am terribly, terribly unshocked to find out the problem followed the tube. Just got a bad pair of 6v6s. So into the bin they go. And those, I want to mention that all the voltages I was just measuring were with the current limiter in place. I'm pretty sure that without that current limiter in place, that one tube that I was getting 81% would have gone into runaway conditions and blown this fuse. So we're going to put in a test pair of 6v6s and see how things are looking. Okay, new pair, well, test pair of groove tube 6L6s, which I believe are JJs. And with the JJs being 14 watt tubes, the current draw is 52% idle and 51% idle. With a pair of 12 volt tubes, that'd be closer to 60% idle. either way is a good place for this to be, and I will talk to the owner about which tubes we're going to put in here, probably another pair of electro harmonics. Despite the failure of this previous pair, they do tend to be the most reliable 6v6 on the market this year, especially in the combo where the JJs are prone to becoming microphonic, which is why this pair of groove tubes became a test pair. But now that the tubes are idling pretty much identical, the matching is good, there's common mode cancellation, the hum is pretty much gone. So I'm gonna let this run for a while, and I'll talk to the owner, get some tubes, and put the real tubes in there and bias it all up. And then we'll get a real playing video, because it's nice to have a real playing video of a 64 Deluxe up on the channel with the Fender Electric Instrument Company, Fullerton, California, loud and proud. But it's also nice to know that of all the work I did in 2018 is all holding up just fine. It's just a current production output tube that could not go the distance. Now, the owner of this amp also brought an old Pro Reverb that's also blowing fuses, so we'll check that one out soon too.